Welcome. In this video, we're going to introduce indeterminate forms and L'Hopital's rule. So if you recall, when we first learned what derivatives are, we began with limits. From that, we use this definition to define the derivative. In a sense, we'll be doing the reverse. We're going to use derivatives to help us find limits. In particular, we're going to focus on limits that have what's called an indeterminate form. But before we start on that, let's warm up with a couple of problems. Here's the first warm-up. Let's find the limit as x approaches 3 of x squared minus 9 divided by x minus 3. We start by factoring the numerator. We have an x minus 3 in common, so these divide to 1. This leaves us with the limit as x approaches 3 of x plus 3. We can now apply the direct substitution step directly. So the limit of x squared minus 9 divided by x minus 3 as x approaches 3 is equal to 6. Let's look at our next warm-up. We have the limit of 4x squared minus 3x quantity divided by 1 minus 5x squared as x approaches infinity. For this one, we want to divide by 1 over x squared on both the numerator and the denominator. After dividing, we end up with 4 minus 3 over x in our numerator. In our denominator, we have 1 over x squared minus 5, and our limit is still as x approaches infinity. Well, as x approaches infinity, 3 over x approaches 0, and 1 over x squared also approaches 0. So our limit simply becomes 4 over negative 5. So the limit of 4x squared minus 3x divided by 1 minus 5x squared as x approaches infinity is negative 4/5. All right, now let's discuss what we just did. So notice in part A, as x approached 3, both the numerator and the denominator approached 0. So in our numerator, we had x squared minus 9, and that was approaching 0. We also had x minus 3 in our denominator, and that was approaching 0. In our denominator. So both of them approached 0. So we had a form that looked like 0 over 0 in this case for part A. We had some function approaching 0 in the numerator and some function approaching 0 in the denominator. Now in part B, as x approached infinity, what did we end up with? Well, our numerator of 4x squared minus 3x approached infinity, and our denominator of 1 minus 5x squared approached negative infinity. So in this case, we had something of the form infinity over infinity, and this could be plus or minus. And these are called indeterminate forms. So methods like what we used above, like algebraic manipulation, do not always work, and this is where L'Hopital's rule comes in.